we will start with something very simple and we will create our own sum function. The name of that function will be sum function. Now I intentionally used the function word here in the name of the function to signify that it's actually a function, but this actually has no real effect. You can just as easily name it some pancakes. It's still going to work. So it doesn't matter how you name it. I'm simply going to name it some function. Don't use the sum name by itself because we already have a built-in MATLAB sum function, and then we'll have ambiguity between the two functions. MATLAB won't know which function you actually want to call. Now, after that, you have to use AND, and whatever code you put between the function keyword and the AND keyword is the code of that function. After that, you have to save this file, and you have to save it with the same name as the name of your function. So we named it sum function. Our file must also be called sum function. Save. Now, the first thing that you should note here is that it has a different icon. As you can see right here, it says fx, while our normal script files, this is a file that we are going to use now to test the function, have the MATLAB icon. So this is a function file, the other files are script files. Now, the function needs to take in some arguments. In our example, that will be a vector. In order to make your function take arguments, you have to use brackets right after the name of the function. And that is where you will specify all of your input arguments. In our example, that is just one single vector, so we will simply use v. That will be the name of the vector that we will use in our code. If you need to use more arguments, you simply list them with commas in between. You can have as many arguments as you want. We will work with just one for now. Let's also create a sum variable. So our sum equals to 0. We're going to use this sum variable to calculate the sum. We will save the result of the calculations in that variable. And calculating a sum of a vector is actually a very easy task. We will simply go through each of the elements of the vector and add them to our sum variable, which we are going to do with a for loop. So for I equals to from 1 to the length of v, we're going to say our sum equals to our sum plus v of I, and that's everything that there is to summing a vector. The loop will run from 1 to the length of the vector, so this will work for vectors of any sizes, and here we are saving our results. After we have the sum, we are simply going to print the result of the sum on our command window. We're going to output it. Now, if you try to run this script the normal way by pressing the run button, you will be surprised it's actually not going to run. The reason for this is that this is now a function, and this function requires an input. It requires a vector input. Function can't do anything without its input. So in order to use this function, we have to give it a vector. We can use it from the command window. So we can say sum function, give it a vector, let's say 1, 2, 3, 4, and 5. Run it, and there we have it. Our sum is 15. Now we can reuse this function as many times as we want. If we want, we can create one new MATLAB file, one new script file, and we can use our function in that file. So let's create 3 different vectors from 1 to 10, from 10 to 100 with increment of 10, and from 100 increments to 1000. Now we can reuse the sum function for each of these vectors. So sum function of v1, sum function of v2, sum function of v3, and if we run it, we get the 3 different sums. Now we can use CLC right here. Alright, and there we have it. Another example of a function is we can create a simple function that will create a plot with predefined stylings, so that you don't have to always rewrite all of the stylings that you're normally using. So we can create a function, let's call it new plot, and that function will take in 2 arguments, x and y, and inside the function, we're simply going to plot x and y. So we're going to say plot x, y. We're going to turn on the grid. We're also going to add some stylings to the plot itself. So let's make it blue. Let's make it line width of 2. Let's also add a marker. So let's make the marker a circle, and let's give it a color. So marker edge color, let's make it, I don't know, red. All right, and we can also, let's say we can add limits. So we can say x limit is the minimum of x, maximum of x, and y limit, min of y, max of y. And you can add some other stylings that you may wish to have. After that, we are going to save the function in a new file. So we're going to call it new plot. Now new plot, the name of the file must be the same as the name of the function. Save. As you can see, again a different icon. And now if we go back to our new function where we are testing our functions, here I can say new plot of v1 and v2. So I'm going to use the two vectors that we already have generated, and I'm going to run it. And as you can see, we generated our plot. We have the markers, the circles with the red color. They're a little bolder from the line width. And we can also, all right, so maybe not everything here is actually correct. So let's do it like that. Let's remove this from here and say marker like that. And let's rerun it, and there we have it. Now, this is a predefined styling. No matter what vectors you give it, you're simply saying new plot, vector 1, vector 2, and it will always apply these stylings. So if you have a preferred styling that you tend to use all the time, you can create a function that will always generate these stylings. The limits are also automatically generated. You can add additional arguments for your plot, for the labels and the title, for example. So you can say x name, y name, and plot name, and you can use them. So x label will be x name, y label will be y name, title will be plot name, and back in the function here we simply need to specify them. So first vector, second vector, and the title will be, well, just 2 vectors. And if we run it, there we have it. We have our labels, we have our plot, everything we did it with just one single line of code. And here we have 7 lines of code, and there you have it. Just think about it. Think, what are you doing all the time that you can extract in a function to increase your productivity, to spend less time writing the same code over and over again.